In our Sandbox experiment, we conduct 3 different scenarios, with all factors held constant except the inclination. The model consists of 3 different sand layers representing sediments, each with a thickness of 1 centimeter and with equal grain size. The sandpaper was of grain size 240 by the tsunamis scale.
Accommodated by nucleation of new thrusts in front of the wedge, accretion of sediments thickens the wedge and raises the surface topography, rendering the wedge unstable. A stable geometry can be regained by internal deformation, most commonly involving shortening, imbricating and folding. The material within the wedge deforms until it develops a critical taper, and basal shear and wedge translation can occur. Internal and basal shear stresses are balanced in critical state. The wedge experiences significant shortening after a new thrust initiates, leading to a decrease in wedge width. In reality, as the wedge grows, new material is added, with the thrust wedge accreting in a piggyback style during its forward advance. As real-world thrust wedges develop, they do so by the addition of discrete, often large, thrust sheets. Evolution of the wedge taper angle occurs by progressive internal deformation and accretion of new units to the wedge front. In the 3 models, we observe the thickness changing in the kink band as a result from the simple shear when the sandpaper is pulled. Comparing the experiments, we notice the number of thrusts is quite similar. The angles become gentler at the end of the taper. As we increase the gradient of the sandbox, the average back thrust angle becomes smaller. The shortening increases as the gradient of the sandbox increases. There are 3 distinct regions. The thrust wedge involves growth that repeats episodically and cyclically. In the second and third experiments, a critically tapered Coulomb thrust wedge developed with the thrust-related anticlines forming in a piggyback sequence and progressively younger structures nucleating forelandward of the older one. Thrust-related folds develop in each experiment before a stable critically tapered Coulomb wedge formed and slid along the decomo with no further internal deformation.